Alright, let's see the 10th day challenge from the lead code, which is min stack. So here we are going to design a stack. That stack supports the following methods: push, pop, top, and get min. Push method takes an input parameter and push the element onto the stack, and then pop removes the element on the top of the stack. Top gets the top of the element, and get min retrieve the minimum element in the stack, right? So what I'm going to do is I'm going to write the code first, then I'll go through the example, and then I'll calculate the runtime and then space complexity, right? So there's a hint there. In the hint they are saying like, hey, you can use a min variable, min value when you're creating a stack. So we are going to have to create a class node, right? In the node class I'm going to have int min, int data, int next, right? And then in the constructor of the class I'll be taking int int data, int min, right? And then this dot min is equal to min, and then this dot data is equal to data. Okay, so this is the class. The first thing we did was just create this class, and then we are going to use this class for creating stack, right? And then first of all I'm going to just have a class level variable node head, right? And let's see what are the methods we are going to have. The first one is the push method. Okay, so and public void push int data, right? So and then I'm going to create a temporary node variable here, and then if head is equal to null, which means there is no elements in the stack. So temp is equal to new node, and it's going to use the data and then data, right? And else, that means we already have some elements in the stack. So what I'm going to do is temp is equal to new node, and the first one is data, and the second one is math.min head.min or the given data. So what we are doing here is, I'll explain one more time when I'm explaining the example, but here when we are creating the node and we are using this given data and for the min variable, right, and we are checking whether the head min or the given data, which one is smaller, and the smaller one we are going to assign to create the temp, right? And then temp dot next is head, and then head is going to be now temp, right? We should make sure to keep the pointer head, right? So this is the method for push. And then the second method what we are doing is push, and then get min. Okay, so get min, public void get min here, get min. Excuse me, it's not void, it's returning an integer, so it's supposed to be public int get min, right? Okay, so now what this method's gonna do, it's gonna return the minimum value from the stack, right? So I'll be checking first if head is equal to null, that means empty, I'll be returning -1. Otherwise return head dot min, right? And then what is the other method? Push get min pop. Okay, let's see the pop. Public void pop. Okay, if head is not equal to null, head is equal to head dot next, right? That's all this pop does. The pop is the one, when let's make it sure, yeah, it's going to actually, let's see, the pop removes the element on the top of the stack. So I'm checking in the pop header, the head is not null. If it's not null, head is equal to head dot next, right? And then otherwise the last method is public int get, I think it's get top. Let's double check the name. Mean top, top, not get, not top. Okay, top. So what this method does, if head is null, again if the head is null, I'm going to return -1. Otherwise, return head dot data. Okay, and so let's make sure we have this class, we have these three variables, two integers, and then class level variable node. Next, and then the constructor we are getting two input parameters, and then I am assigning in min is equal to this min, data is going to be this data, and once I get out from this class I have a class level variable head, and when I am pushing it I am creating a temporary class not temporary variable, not type temporary variable, and then I'm checking whether the head is null. If the head is null, there is no stack elements. When this is the first time I'm invoking this push method, so the head is null. I am creating a new node, and then I'm setting this head. I'm just assigning this create a new node is the head. Otherwise we already have a value, so we are getting the creating the node and then checking the minimum value, which one is minimum, and then I am make sure to point the head to the next element from this element, and then when I'm getting the get min, I'm checking where the head is not null, then if it's not null, I'm returning the min, and that should be it. So this is the code for creating a min stack. Let me run and see whether I made any mistakes or not. Oh, interesting. Node.next. Okay, so obviously I made some typo in the, let me see the line number. Line 7, lines, oh my word. Okay, not next. So let me just run the code again. Your answer null, expected answer. Okay, your answer null, -3 0 -2. Okay, so this is the code for creating the min stack, and let's quickly analyze the runtime complexity. So when we are pushing the element, it's going to like create the node and then set into the next one, and so I am not iterating all the elements in the stack, I'm just creating it. So big O of 1, so the runtime complexity for the getMin also big O of 1, and then this one also big O of 1. So let me see the time complexity. Time complexity is big O of 1, and then space complexity also. So with space complexity, when I'm doing what I'm doing is big O. If we have n elements, big O of n elements we are going to have, and also here I'm using the min variable. I am not creating two separate stacks to maintain the min value. So the space complexity is going to be, if it's n element we are going to store, it's going to be big O of n. So that's how you can solve the min stack problem. Okay, let me submit. I already submitted this code. I just want to submit it again. Okay, see, it's accepted. So thank you so much for viewing this video, and please let me know if you find any corrections. Thank you.